All right, hello and welcome everyone. This is Noah again, and in this video we're going to look at converting a quadratic function to vertex form and then graphing that function. All right, so we have finally made it to the final topic for module 4f. I know this is a bit of a longer one. Good job sticking through it. It's just kind of putting it all together, right? We've done the vertex form, graphing something in vertex form. We've done converting something to vertex form. We're just now going to do them both at the same time. So given the following quadratic functions given in standard form, we want to convert them to vertex form, find the vertex, y-intercept mirror point, the x-intercepts, 2 additional points, and graph the function. So I've got f of x here, and I'm just going to start by converting it to vertex form real quick. Nice thing, this one has a leading coefficient of 1, so I don't have to worry about a bunch of extra brackets here. I can just go skip a little space and write x minus 6 quantity squared, right? Half of that minus 12 is minus 6. But by consequence, this added 36 to our expression, so I need to take 36 away as well to keep everything in balance. Bring down that minus 36, and then bring down the plus 7 that had just been hanging out front. I'll go ahead and simplify this then to x minus 6 quantity squared minus 36 plus 7, that's minus 29, yeah? All right, so the vertex, we can see right away here, that is the point 6, comma, negative 29. And then we can actually get the y-intercept from the beginning pretty easily. Excuse me. If I plug in 0 for x, I will get 7 out, right? Right here, those terms would go away. So we get the y-intercept of 0, 7. That. And then the mirror, the y-intercept mirror, is going to be, if I take the vertex and double it, I'm going to get 12, comma, and the y value of the y-intercept is 7. So let's see that. Let's start graphing this now before we find anything else. We've got those 3 key points, and the vertex is to the right. Let's start over here. The vertex is really far down there. This is opening upward because it's a positive leading coefficient. If we're going, vertex is negative 29 up to a y-intercept with a 7. It's a 36 total, so I need to have like 18 of these and be able to go by 2s. I think this is enough. Let's take a look here. So y-axis, x-axis. If this is 6 here, negative 9. The y-intercept of 0, 7 would be, whoops, sorry, that's negative 6, and negative 12, negative 18, negative 24, negative 30. Yeah, just enough space there. So each of these lines is, each of the grid lines is worth 2. The y-intercept of 0, 7 is all the way up here, 0, 7. And then we want the vertex at 6, so if I do 6 here, and this is 12, and that would make this maybe a little easier. 6, negative 29 would be here. And that y-intercept mirror point is going to be the axis of symmetry is here, and so that's going to double over to 12, just like we predicted there. 12, 7. And then we need these x-intercepts. looks like they're not going to be too pretty, but let's go ahead and get them real quick anyways, and then we'll go ahead and plug in a couple of more numbers. So 0 equals x squared minus 12x plus, 0 equals, do this in Vertex for it will be easier, x minus 6 squared minus 29. Add the 29 to the other side. So we'll get 29 equals x minus 6 squared, and then we can take the square root of both sides. But remember to put that plus or minus in front of that square root when you do so. So we'll get plus or minus square root of 29. 29 is prime. I can't really do anything with that. And then I'll just, the square root and the square cancel on the other side, give me just an x minus 6. I can add that to both sides to get 6 plus or minus the square root of 29 equals x. So the x-intercepts are the points 6 plus the square root of 29, comma 0, and 6 minus the square root of 29. All right, again, I'm not exactly sure where those are. It's the square root of 29 is a little bit bigger than 5. I know that because the square root of 25 is 5, and 29 is a little bit bigger than 25. So we're looking at something around like 11 point something, and then around 0 point something in that one. But that's okay. We don't even need to know that right now. We could plug it into the calculator and get approximations and plot those. But I'm going to go ahead and instead I'm going to plug in like 1 into this function, right? See if I can get a point in that region. So f of 1 is going to be 1 minus 6 is negative 5 squared, and then minus 29. So it'd be 25 minus 29 equals negative 4. So 1 is going by 2, so 1 and then negative 4 is there. And then this is going to reflect over that axis of symmetry. 2 over here, this is 11, comma negative 4. All right, so we can start graphing this at this point. This is really vertical in here. Just with my scale the way it is. So I think I want to get one more point in here. Like I'm going to plug in 4 into that function as well, just to help me draw this a little bit nicer. So if I do that, I'm going to get negative 2 squared minus 29. Right, 4 minus 6 is negative 2. So we get 4 minus 29 equals negative 25. So 4, negative 25, that's there. And then its mirror is going to be just on the other side of that vertex. So that helps a bit. Gives me a place to aim as I'm drawing. And I'll turn this into a U at the bottom. And there we go. This was, let's see, this was the point 4, negative 25. So then we went 2 over and 2 over is 8, comma negative 25. Cool. And then those x-intercepts, we can now go ahead and plot. All right. The first one is going to be the 6 minus the square root of 29, comma 0. And the second one over here, this is the 6 plus the square root of 29, comma 0. So 6 is in the middle, and so that's to the right of that axis of symmetry there. All right, I'll label my function y equals f of x as my little signature here and call it good. All right, let's see what happens in this next one. We've got g of x equals negative 6x squared minus 12x plus 5. Room here. This one has a leading coefficient of -6, so this is definitely going to need us to factor out, just looking at those first two terms, if I factor out that -6, then we'll have x squared plus 2x. Right? Remember, we factor out that negative as well, so that's why it's a plus 2 in there. It's really important that we keep that in mind. I'll leave a little bit more space here. Plus 5, just for my eyes to see something a little bit nicer here in a second. So I've got that -6, open up that bracket, and this is going to be a x plus 1 squared right there. What happens with that is that by consequence, right, that half of 2 is 1. By consequence, when I square the 1, that adds a 1, and it's inside these brackets when I do that. So I also need to subtract 1 here. Subtract 1 down here. That is inside that bracket. That's really important. And then I'll bring down the plus 5. So then the -6 can distribute across the minus in front of the 1. And this will be -6 parentheses x plus 1 squared plus 6 plus 5. And I can simplify here. -6 times x plus 1 squared plus 11. Whew, all right, we had some work just to get it into vertex form, but we can now see that the vertex is the point -1, 11. We know that this is downward facing. The y-intercept I'm going to get from the standard form. The y-intercept is going to equal 0, 5, right? If we plug in 0 for x, we get 5 for y. And so the y-intercept's mirror point is going to equal -2, 5. Right? The 5 from the y-intercept stays the same. And then the x value is twice that of the x value of the vertex. And we'll see that in the graph here in a second as well. Vertex is at 11, so pretty high up. It's just to the left of the y-axis. Y-intercept's at 5. So this is downward facing. Let's give ourselves just a little bit of really low. X-axis, y-axis. Can we get all the way to 11 here? 2, 3, 4. Here's 5. Let's go by 4s. There's 4, then 8, then 12. And we'll just go by 1s again over here. -4, -8. Positive 4 over here. -1, 11 is my vertex up here. -1, 11. And then the y-intercept of 0, 5. You can see already how stretched this is. So that mirror is going to be at -2, 5. And if we try and draw this as a parabola, we see like how skinny this is. So I'm expecting these x-intercepts to be like around 1/2 and -2.5, so they're not going to be pretty numbers again. So let's set the output to 0. 0 equals -6 times x plus 1 squared plus 11. Subtract 11 over. -11 equals -6 times x plus 1 squared. And then divide both sides by -6 to get 11 over 6 equals x plus 1 quantity squared. Then I'll take the square root of both sides. not forgetting my plus or minus. And I will get plus or minus the square root of 11 over 6 equals x plus 1. Subtract the 1 over to the other side to get x by itself. And this will give us negative 1 plus or minus the square root of 11 over 6 equals x. So the x-intercepts are the points negative 1 plus the square root of 11 over 6, all of that inside there. I could rationalize that if I wanted to. I'm not going to worry about it at the moment. And the other x-intercept is negative 1 minus the square root of 11 over 6, comma 0. All right, but to plot that, I think I want to plug in like negative 2 or positive 1. Let's plug in a positive number. That seems a little bit easier. So I'll say, what is g of 1? And I like doing that in the vertex form. It just seems a little bit faster. So I'm going to get negative 6 times 2 squared plus 11 is negative 6 times 4 is negative 24 plus 11 equals negative 13. Oh, that's already way down there. So let's see how skinny this graph really is. I wasn't expecting it to be that far down, but that's okay. 4, 8, and 11, 12, 13, 12, negative 4, negative 8, negative 12, negative 13 is right there. So yeah, and then if we mirror this over the negative 1 value, it's going to be negative 3 comma negative 13 and 1 comma negative 13. There we go. All right, so we can label these x-intercepts now. We have this x-intercept at negative 1 plus the square root of 11 over 6, comma 0. And then our other x-intercept over here at negative 1 minus the square root of 11 over 6, comma 0. And we'll sign off with y equals g of x. And that's it. Whew, all right, so these are definitely a little tedious here sometimes, but we have these tools to graph these parabolas by hand. And what's nice is we can see a lot of the elements. We can kind of get an idea of what the graph looks like pretty quickly with that vertex and the stretch factor and the y-intercept. So we see that it's downward facing. So even though it takes a lot of time and energy to go through and get the details and get a really nice, detailed, pretty graph drawn, the quick sketch, the basic idea of what it looks like, hopefully you're starting to be able to see that as you go through these. All right, we're going to call that a wrap on this video. Go ahead and do the Now You Try problems, and I'll go through the solutions of those in the next one. Thank you much. See you soon.